And you know that you will have to deal with the pandas always, because even while data analysis, data manipulation, time series analysis, data cleaning and preparation, statistical analysis, performance and scalability, visualization, data integration, backtesting, and strategy development, whether it's a red candle or a green candle. So for that, what you will do, so you will check whether the open price is greater than the close price or not. If the open price is greater, I want to print only the initial 5 rows and up to the market cap. I don't want these columns, right? So the first column, company name, sector, industry, and market cap. So for that, what you will do here, welcome back to the day 25 of the 100 days of hell with Python algo trading. In previous session, we have covered Pandas series, and today we'll be covering the Pandas DataFrame. And you know that you will have to deal with the pandas always, because even while data analysis, data manipulation, time series analysis, data cleaning and preparation, statistical analysis, performance and scalability, visualization, data integration, backtesting, and strategy development. So in order to efficiently work with all of these things, you have to know the deep concepts of Pandas series and DataFrame. So today we will be diving very deep in the Pandas DataFrame, and you will realize after this session that how important it is. And once you have attempted all the multiple choice questions and the task questions, you will feel so powerful. And just with the help of few more libraries like very easy, the Matplotlib and Seaborn, you will see that how amazing things we can do with the Pandas library. So let me quickly show you that what you can achieve with the Pandas DataFrame. So without a further ado, let's deep dive in the amazing world of Pandas DataFrame. So before starting with the coding examples, let me tell you what is OHLC. So OHLC stands for open, high, low, and close. And sometimes we also use V along with OHLC. So V stands for volume. So generally, whenever we fetch data from any source, be it a crypto exchange, a forex exchange, or a traditional stock market, you will always get the same data, and that is OHLC V, right? And that is what needed for your trading or algo trading, right? So as I have used the OHLC data in previous videos, so before going further, let me first clearly explain you how does this OHLC works. Okay, so let's get started with OHLC. So here on the screen, you can see that we have two candles. One is green and another is red, right? So if you can see, it is clearly written that we have a low, a high on the green candle. Similarly, a low and high on the red candle, right? Similarly, we have an open and a close on green candle, but in red candle, it is different. The open is on the top and the close is on the bottom. So how does we define this OHLCV? So let me show you. So generally, so whenever you see any trading chart, you will see these type of data. It can be a candlestick chart, it can be a bar, or it can be any other type of bar or candlesticks. But more or less, you will have this kind of structure, right? So here, if you can see, you will observe that from here, this place, the price is going up. This phase is known as the manipulation, right? Okay, so along with OHLCV, you will also learn something else. Again, this price will increase from here to here, and this phase is known as the distribution, right? Distribution. And again, here it comes the manipulation. And this will also the distribution, correct? And here you can say it is manipulation, and this little bit phase known as the accumulation, right? Okay, then what else we have in this chart? Okay, let's focus on one candle. So I'll remove this for now. You will see that this one candle dropped from this place to this place, right? So we can say that this candle started from this point and closed at this point, right? So you can say this is known as the open of this red candle and this is the close, correct? Then let's say if this candle was of the 1 hour chart, okay, 1 hour. So means we can say in 1 hour, there were multiple 1 minutes or 5 minutes candles, right? So what happened in that particular 1 hour, this candle reached at this point, the top, this point, right? So you can draw a line here and you can mark it as the high of that particular candle. And also this candle reached the low of this point, right? So you can mark it as the low. Hope now you are able to understand that this candle opened at this point, which is the open, and closed at this, which is known as the close. And in that particular 1 hour, it reached to this highest point, and this lowest point. So these are known as the high and low. So let's give it some value. So opened at 100, right? And closed at 80. And we can consider high as 120 and low as 60, right? Hope it's clear. So this OHLC data is for this red candle, we can say OHLC, and this is the volume. So sometimes we also need a volume also. So we say OHLCV, correct? Similarly, when we check about the green candle, so what happened here? This green candle opened at this place, this point O, closed at this point, which is C, and in this 1 hour, it reached to the highest point of this, right? And the lowest point of this one. This is lowest, this is highest, correct? So again, you can give some values here. So opened at, let's say, 80 and closed at, let's say, 85, correct? Highest you can give it as 90 and lowest you can give it as, let's say, 75. So this is the OHLC data of this green candle, correct? The only thing you need to notice here is that in red candle, the open is at the top, and in green candle, the open is at the bottom, right? Similarly, in red candle, the close is at the bottom, but the close in green candle is at the top, right? Hope it's clear. And if you still have any doubt, you can let me know in the comments and I can repeat this again in any other video, right? Okay, now let me compare this with a data frame. So now if you can see on the screen that we have data of 1 day, right? You can see here, this is 1st January 2015, this is 2nd January 2015, right? So let's suppose these all candles are 1 day chart. So let's suppose these all candles are 1 day chart. Means each one candle represents a single day, right? So you can say here that open is 101, right? So let me just remove this one first. So now how you can identify from a data frame that whether it's a red candle or a green candle. So for that, what you will do, so you will check whether the open price is greater than the close price or not. If the open price is greater than the close price, so means if the open price is greater than the close price, means that is a red candle, correct? And if the open price is less than the close price, means that is a green candle. As simple as that. Let me show you how again. So let's see on this first row, this one, you can see here open is 101.03 and close is 101.19, means open is less than the close, means that is the green candle. And we can also represent that in a candle. Let's say open means this open is 101, right? Then close is 101. So let's suppose this is the close, correct? So open is below the close, means that is the green candle. Again, let's check on the next row, and here the open is 100 and low is 99, means now the open is greater than the close, right? So we can say means this open is greater than the close, which is here, and this is a red candle. I hope you are able to understand what I'm trying to say. And this volume is this candle, this one, this bar is the volume bar. Don't worry, we will understand this in detail in further videos. But for now, as we are using this OHLCV data, that's why I thought it's important to explain you the OHLCV data, right? Hope it's crystal clear for you now. But if you still have any doubt, please let us know in the comments and we'll be happy to help you. And you can also let us know that which kind of explanation you like and how we can improve the explanation for you and what else you need for your better understanding. So with that being said, let's dive into the coding part. Okay, so let's create a data frame. So we have seen that a data frame is nothing but a combination of multiple series, or we can say a series is nothing but a single column or a single row of a data frame. And we know that the pandas consider a table as a data frame, right? So let's quickly go and create a data frame with the help of a list. So let's say I'll create a 2D list, right? And inside that I'll give some price data. So let's say 1, let's take 100, 200, 300, 400, and 600, right? And inside that I'll pass multiple lists. So what I'll do, I'll just give here a comma, then again a list, comma, then again a list, a comma, and again a list. So means we have a 2D list, right? And now what we can do, we can simply write the PD data frame class, and inside that we can pass this price data list. So when we hit shift enter, it says PD is not defined. Why? Because we have to run this cell, and we have seen that whenever we import pandas library, please import numpy also along with the pandas. So I'll go here and hit shift enter, and now when I run this, you will see that we have a data frame created. So what I'll do here, I will just save it to a, let's say, list df, and so when I check the type of this list data frame, you will see that it is a data frame, right? Similarly, we can create a list with the help of dictionary, and that is slightly easier than the list. So what I'll do here, I'll just copy and paste the same data, and I will try to create a dictionary first. So let's keep the variable as same, and I'll remove this, and I'll add a bracket here, and then I will create some keys and value. So let's keep these value same, and I'll create some keys here. So let's say OHLC. So open, right? And I'll just copy it and paste it here. Open, high, low, and close. I'll just change this high, low, and close. Correct? So similarly, I'll go here and I'll write pd dot data frame, and I'll pass price data here and hit shift enter. And you will see that we have a data frame with the dictionary. And here also we can add another column, and let's say give it the name. I'll copy it and paste it here, and let's give the name, and in this name I can give some name of the stock. So let's say, let's keep it Apple, then we can keep it Microsoft, we can keep it as Tesla, and let's keep this as Meta, right? And now when we shift enter, you will see that the first column is with the name of the stocks, and then we have the OHLC value of those stocks, right? And also you will observe that we have an index, that is a default index, which we have seen previously in the series also, that whenever we create a data frame, we always have an index, default index, right? And if you want, we can even replace this with the column name. So what I'll do here, I'll go and first I will store it as let's say ticked df. Let's hit shift enter, and now I will change the index. So dict df, and I'll use a function that is set index, which we will read in this lecture. So for now, just remember this, that set index, and here you have to give the name of the column. And so we know that the name is name, right? And now when you hit shift enter, it says invalid syntax. Why? Okay, we have to remove this one. Yeah. So now you can see that we have the index, but still it is not permanent. So let's say in the next line, when I check, it is still the default index. So for that, we need to use a hidden parameter, that is in place. In place is equals to true. And when you hit shift enter, now you will see that we have the permanent index as the name. So we have seen that we can create a data frame with the list and also with the dictionary. Now let's move that how we can create a data frame with the CSV. And actually in the real life scenarios, you will be getting a data frame maybe in the form of API, or you will get a CSV. And with that, you will have to create a new data frame. You will not create with the list or dictionaries. It was just for the understanding, right? So here I have two CSVs. So to follow along, what you do, you just go to GitHub and download these two data sets, or you can just clone this GitHub repository in your local and you can use these data sets. Okay, let me show you these data sets. So in this algo trading combined data set, we have multiple types of data like the stocks, crypto data. And in the second data set, we have the fundamental research of the stocks. So in that, we have the sector, the stock name, and like the prices, right? So you can download and you can use it. Okay, so let's import this. So what I'll do here, so to create a data frame with the CSV, what you can do, you can just use the function read CSV, right? And you can import the file. So we have the file with the name Algo Trading Combined Dataset. So Algo Trading Combined Dataset. And when you hit Shift Enter, you will see that you have the data frame here, and the number of rows are 32,000 and the number of columns are 7, right? So what I'll do, I'll store it in a variable, and let's say the variable name is AlgoDF, okay? Algo data frame. And let's import this one also, this fundamental research CSV. So I'll write pd read CSV and the name of the file, that is fundamental research dataset large and CSV. So now when I hit Shift Enter, you will see that we have the data frame with the 1050 rows and 10 columns. So I will store this also in variable, and we can give it the name as, let's say, funda.df, correct? And hit Shift Enter here also and here also. And let's print the algo.df and the funda.df. Hopefully it's clear. It's very easy. You just have to use the read CSV function, and then you have to give the name of the CSV file, correct? Now we have some data frame attributes and methods. Similarly, which we have studied for the series also. So in data frame, the first attribute we have is the shape. So let's check the shape of both the data frames. So algo.df.shape, and you will see that it will give us the shape of the data frame, which means the number of rows and the number of columns. Similarly, you can check the shape of the second data frame, that is funda.df and shape. You will see the shape of the second data frame, that is 1050 rows and 10 columns. Again, in the D types, it will show you the D types. It will show you the data type of each row, right? So here the date, ticker, open, high, low, close, volume, and you will see that object, and rest all are the float 64. And you know that the object is considered as string in data frame, right? Let's check the D type of funda.df, D type, and you can see that we have the 4 columns of object and rest are float 64. Okay, next we have is the index attribute. So let's check the index of algo.df, and you will see that we have a range index, right? Start from 0 and stops at 32870 and step 1. So range index is nothing, but we have already studied about this previously, the range function. So in that we get a range. Similarly, here we get a range index, right? And we can check for the funda.df also, funda.df and index, and you will see a range index from 0 to 1050. Next we have is the column attribute. So it will display all the column names of any data frame. So let's check the column of algo.df, and it will print out all the column names. It says algo.df is not defined. Actually, I restarted this kernel. That's why we have to again run this one. So I'll go here and run this. Actually, I have to run from starting, and now I will again run this cell and this also. Now it should work. So when I run this, we'll get the name of all columns. Similarly, you can check for the funda.df. So funda.df dot columns, and it will give you all the column names. Next is the values. So you know that we have index and values. So with the values, you will get all the value of the particular data frame. So let's check algo.df dot values, and it will give you an array, and that will be 2D array, right? And for funda.df also, you can check and you will get a 2D array, correct? But it's not that useful for us. but sometimes you can use some Python functions and you can use this. Okay, now let's check some methods of the data frame. First, we have head and tail, which is exactly same like this series. So let's check algo df.head. It will give you the first 5 rows of the data frame. Similarly, you can use tail here and it will give you the last 5 rows of the data frame, right? And you can also use the custom values here. Let's say you want last 20 rows. So you can use 20 here and hit shift enter and you will get the last 20 values, or you can say last 20 rows. Then we have sample, which is also same. So it will randomly select any row of the data frame and it will print out that. If you run it again, you will get another row. Again, you will get another row, right? And here also you can use custom values. Let's say you want 10 sample values. So it will give you 10 random values from the data frame. You can see here. You can again run this. You can use this method when you have bias in your data, right? Bias means maybe your data is slightly tilted towards any one side, right? So that time you can use the sample method. Next, we have a very useful method, that is info. So if you apply this on the data frame, the info method will give us a lot of information, like the number of entries, the number of columns, and the non-null values, right? And the data type of that particular column, and again the memory uses of that particular data frame, correct? Similarly, you can also use this on the Funda df and info, and you will see that it will give us the output of this. And you can see here it is using 82.2 KB and it has 10 columns and 1050 entries, the number of rows. Next method we have is the describe. Describe gives you the mathematical information of that particular data frame. So it will be applicable only on the numerical columns. So let's apply on the algo df describe, and you will see that it will give you the count, mean, standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, and the max on all the columns. Next we have is the is null, and this function is really useful. Let's apply on this algo df is null, and it will go to every value and it will ask are you null, and if it is true then it will give us a true value, else a false value. So to quickly calculate the number of null values, you can just apply another function, or you can change the method, that is sum, and it will calculate the total number of null values in the data frame. So you can see that in date and ticker we do not have any null value, but in open, high, low, close, and volume we have these many null values. It can quickly calculate that. Why? Because we know that the value of false is 0 and the value of true is 1. So it will quickly calculate all the ones and you will get the answer quickly, right? Similarly, you can also apply this on the Funda df. So let's check how many null values are there, and is null, and then you sum it with the method chaining, and you will see that it has these many null values in the market cap, EPS, DE ratio, and so on, so forth. Next method we have is the duplicated, and this is very important because you will be always using this duplicated method. Why? Because you will have to find all the duplicate values from your data set, because those values always create some issue, right, while analyzing. So what we will do here, algo df, and we will apply duplicated method, and you will see that it will show you that which row have duplicate value, right? And then you can just apply sum on this also, and you will see that we have 1565 duplicate rows. Okay, let's check the duplicate value in Funda df data frame and duplicated. Then we can give a method chaining and sum. So you will get 50 rows are duplicated, right? So that's how you can analyze the data, and you can find the null values, duplicate values, and that is known as the data cleaning, or you can say data preparation. Okay, next method we have is the rename method can modify the name of your columns. So let's say here we have algo df dot columns, right? And let's say you want to change the value of high low to max min. So what you can do, you can just apply a rename here, and then you can give a column, and then you have to provide the dictionary. So here, first you will give the original name, that is hi, correct? And then the new name. So you want max here. Again, you will give second one, which is low. And instead of that, you want minimum, right? So you will just write min and like this. So now when you hit shift enter, you will see that instead of high and low, you have max and min. And if you want this change permanent, you have to apply in place here, right? And when you make it true, it will be changed permanently. So whenever you apply in place, you have to be double sure that you know what you are doing in the production environment, right? Now we have some math methods, right? First we have is this sum. So you know that sum all the values. So when you apply sum, you will get all the values as, and you can see some interesting stuff here that it has even added the strings, the objects, right? You can see here apple, and here also it added all the dates because these two columns were in the object data type, right? But the rest were floats, so it added like the same usual, correct? You can also apply on the fundamental data frame, and when you sum that, all the values will be added, including the objects, right? So it will concatenate the strings and it will add the float or integers. And you can also apply all those mathematical methods which we applied in this series, like the mean, median, mode, standard deviation, or variance. You can even check. So let's say I have this algo df, and you can check the mean of that, right? It will take, okay, it says could not convert because it cannot apply mean on the strings. So for that, you have to select a specific column or only the columns with the float or integer values. So let's say we apply the mean on the high column, and when you apply on that, you will get the mean of that column, right? Similarly, you can apply the variance also, funda df. Don't worry, we'll understand all these in the future. The variance you can apply on, let's say, the market cap, and when you apply where, you will get the variance of that. Okay. Okay, now we have selecting columns from a data frame, a single column. So we know that we have this data frame, and inside that we have 7 columns. So if you want to select any column, you just have to give the name of that column. So let's say close, you will get the value of close. You can even get the high, you will get the value of high for this single column. Okay, now if you want to select multiple columns, what you can do, let's say you have this data frame, right? And if you want this ticker and the industry and the market cap, so for that, you have to give a list inside a list, right? Then you will give a ticker, sector, and hit shift enter. And if you want something else also, you can get, let's say, market cap, and you will have the market cap. Actually, I think we are, and check, okay, we have this B also here. So now when you hit shift enter, you will get all the 3 columns, right? So it's, I think, quite easy, nothing difficult in this. And you can easily extract the columns from a data frame, right? Okay, now let's understand how to select rows from a data frame. So here we have 2 options. One is iLock and another is lock. So for simplicity or understanding, you can remember that iLock is for the index and lock is for the labels, right? So let me first print our data frame, that is algo df, and let's say I want this first row. So for that, what I'll do, I'll just write algo df and iLock, because here we are printing the row with the number, the index number. So I'll just write 0 and you will get the first row, right? And let me make it single row, and for the multiple, we'll add another cell, and in that I'll just write multiple. And here what we can do, let's say algo df, and I want to print algo df dot iLock, and I want to print multiple lines. So for that, you can use the same indexing which we have used in list, dictionaries, and all those. So here you can use the, like you want to print from 0 to 4. So you can use 0 to 5 and you will get all the initial 4 rows, right? Similarly, let's say if you want to print from the row number 0 to 9. So for that, what you can do, you can write 0 colon 10 and you will get from 0 to 9. And here you can also use this step which we have used previously. So let's say I want all the alternate rows, right? Let's say I want all the alternate rows. So I'll write 2 and you will get alternate rows, right? 0, 2, 4, 6, 8. The interesting thing is that you can also use fancy indexing here. So for that, what I will do, I'll write algo trading and iloc, and inside that, for the fancy indexing, we have to pass a list. So let's say I want to print the row number 1, then I want to print row number 4, then row number 7, then 9, 10, then 13. So why we use the fancy indexing? Because no consistency, right? And there is no pattern. Because here we had a sequence like from 0 to 10, then we can have a step from like 2, 3, 4. But here there is no pattern. So for that, we need to use fancy indexing. And let's say I want to also print the row number 1300. So there is no pattern. We want to just print a random number. So now let's hit Shift Enter and you will get all the rows which we have mentioned in fancy indexing, right? So now let's understand the LOC, right? So we'll try to print the rows with the label index. So let's print the funda.df here. And what I will do, I will try to print, and you will see that all the rows with the index as Apple gets printed out. But we know that there are multiple rows with the same index name, right? So I would like to print few more stock names. So I will check what options are there. We have Google, we have Microsoft. So I'll also add here the Google and also the Microsoft, right? And for that, we have to enclose this in a list. So it will become a fancy indexing with the LOC. And when I Shift Enter, you will see that we have all the rows with the Apple, Google, and Microsoft, correct? One more interesting thing is that if you want, you can still print with the index positions. It is not visible here, but you have to make sure that it is always there behind the scenes. So for that, what you will do, I'll just copy, or let's write in another cell. So funda.df dot iloc, and here I'll give, let's say, from 0 to 10, and you will see that all the rows from 0 to 10 is printed out. You can also use the indexing here, right? It's same, right? Because the index is there, but it is behind the scenes, right? So hope it's clear to you, the iloc and loc. And let's move to the next topic, which is to print both the rows and columns together, right? For that, what I will do, I will write iloc. So first we will check with the iloc. So I'll write iloc. The rows we want from the 0 to 5. So I will write 0 to 4, then a comma, and then again 0, 1, 2, 3. So I have to give 0 to 4, right? And here I want from 4, so I will write 5. And when we hit Shift Enter, you will see that we have only the specific number of rows and columns, right? Similarly, you can also use loc here. So for that, what I'll do here, I'll write funda.df dot loc, and let's say we want to print the rows with the name Apple, and we want to print from company name to market cap. So I'll write company name to market cap. Okay, now if we give here the slicing or step size, then what will happen, as this Apple is not unique here, it will give an error, right? If you try to do that, let me show you. Let's say if I want to print from Apple to Tesla, so what I will give here, TSLA, and you will see that we have an error because there is a conflict of indexes. So for that, I can remove it. We can just print this. And now this is the question for you, that how we can print with the LOC from Apple to Tesla, right? Just pause the video and let me know. Actually, we cannot do that. You can try yourself. You can download this dataset and try. If you get the answer, please let me also know, so I can also learn, right? So now let's do that with the different dataset we have, that is Algo DF. And what I'll do here, I'll first check the content, and then I'll apply LOC, and here I'll give, like, let's say from 0 to 5, the column number, right? So I'll print, it will get printed 0 to 4. Then for the labels, let's say I want to print from date to the close, right? So I'll just write close, and when I hit shift enter, you will see that we have the desired data frame, right? So that's how you can use iLock and lock. We can discuss this further if you have any issue, and please let me know the answer of that issue we got. So next we have is the filtering at data frame. But before that, let me show you how to add a new column, right? So what I'll do here, let's take this Algo DF. We have date, ticker, open, high, low, close, volume. You can just give a new name, let's say new column. The values you can give anything. Let's say you want to give a string, let's say Kuldeep Singh, right? So when you hit shift enter, there is no output, means something has happened permanently. So now if you print that data frame, you will see that we have a new column, that is Kuldeep Singh, right? So that was easy. Let's say you want to add another column from the existing ones. So for that, what you can do, you can write like Algo DF, and let's print any column here, let's say the close, right? And what you will do here, you just have to assign a new name to this Algo DF, and you will say the new close. You will have to do it so many times, new close, because sometimes, let's say if I divided this with any number or multiplied this number, I multiplied this with 100. So you will get a new column with the multiplied value. We will do this a lot of times. I'll show you. Now when you check the data frame, you will see that we have another column with the multiplied values. So that's how you can add new columns, a completely new column, or from the existing ones, right?